Hello, so I'm going to explain MEXT Physics 2015 Undergraduate. Question 5. So, number 1. A glass tube is lying horizontally with the left end open and the right end closed using a movable piston. A speaker with a frequency of F is placed on the left hand side of the tube as shown in figure 5. The position of the piston is expressed by the variable x, which measures the distance from the left end of the tube, moving piston slowly from the position at x equals 0 to the right while the speaker is on. A large sound is heard for the first time at x is equal to L. Moving the piston further, a large sound is heard for the second time at x equal to 3L. Answer the following questions. 1. A large sound is heard because a stationary wave is formed inside the glass tube. Indicate the wavelength of the stationary wave. So the theory that you have to know that when there is two ends here, it will, when there is a wave and there is two ends, whether they're both closed or one of them is open, it will form some sort of lemons. So the wave forms a lemon like this, and one wavelength is defined to be the length of two lemons, and uh, there is an open end and closed end, and you have to know that in open end the wave forms like this, so there is a 2 points here, and when it's a closed end there is only 1 point. And when a closed end, so this is called a node. So when a closed end has a node or meets a node, it produces a large sound. So since at L it's heard a large sound for the first time, we can write that there is a note here, and since this is an open end, we can write this as two lines, and the large sound is heard for the second time at 3L. So at 3L it is 2L apart from L here, so the second note is at here, and from here to here is 1 lemon, so 1 lemon is 2L, and since it is the wavelength is defined by 2 lemons, we just multiply 2L by 2, that is 4L, so the answer is I. Number 2. Find the expression of the speed of sound. So you have to know that phi is equal to lambda times the frequency. So since we know that lambda is 4L, and we know from the problem the frequency is F, the speed of sound is 4FL, that is the answer J. Number 3. Indicate the distance from the left end of the glass tube to the position where the time variation of the density is at a maximum when the large sound is heard for a second time. So time variation of the air density is at a maximum means that means where is the large node, where is the position of the large node when the distance is 3L, and we know that the position of the node is at position L, so the answer is B. Number 4. How does the value L change when the temperature rises? So you have to know that phi is proportional to the temperature. The speed of sound is proportional to the temperature. So we know from before that phi is equal to 4FL, and since T rises, since it is proportional to phi, the phi also rises, and since F is also proportional to phi, the F rises, so the answer is A, it increases. Number 5. increase the frequency of the speaker from F while the position of the piston is fixed at X is equal to 3L. Indicate the frequency when a large sound would next be heard. So, so it means that while the position, so while this end doesn't move at all, the frequency or the number of lemons increases when is the next note will appear. So what multiple of F until the next note appears. So we define uh, this lemon or 1.5 lemon as F, and since until it finds another note, it has to add 1 lemon. So let's go back. So F is equal to 3 half lemon, and we need to add 2 half lemon for it to find the large sound. So to multiply from here to here is just 5/3 of the original F. So the answer is G.